can't draw. That's my boat. This is the water. Boat starts off 172 miles directly west from Johnstown. Travels south, speed of 30 miles per hour. After traveling 126 miles, how fast is the distance between the boat and Johnstown changing? So we want to know how fast this red line is changing. So we'll call this distance y. We don't know how far it is because it depends on how long we've been going. They want to know how fast is that distance changing, because at this instant, this is the distance. We can measure that out. And then at another instant, it's gone even further, so it's going to be even longer. And then we've gone even further away, so it's going to be a little bit longer. So they want to know, if this is y, what is y prime? How fast is that distance changing? This is also a variable, right? This fluctuates depending on time. How far has the boat traveled south? Well, it depends on how many hours we're talking, right? So this is a variable and this is a different variable, but we can relate them to each other through the Pythagorean theorem. This is the hypotenuse, so a squared plus b squared equals c squared. Okay, so that's an equation that relates them to each other. But we know that all of them depend on time. We just don't know what x equals in terms of t. We don't know what y equals in terms of t. So let's take a derivative of this whole thing with respect to t. So we need implicit differentiation, right? That 2 comes down and multiplies, but then what's the derivative of the innermost function? The derivative of x with respect to t is unknown, so we'll call that x prime. And the derivative of a constant with respect to t is just 0. And the derivative of y squared with respect to t, that's also unknown, but we'll use the power rule, and then the chain rule means we need to multiply it to the derivative of the innermost functions. The derivative of y with respect to t is unknown, so we call it y prime. Okay, that's the equation we really need, because we know that it travels south at a speed of 30 miles per hour, so x prime is getting bigger. X is getting bigger, right? That means x prime needs to be positive, because the distance x is increasing by 30 every hour. So what else can we plug in? We can plug in 30 in for x prime. We need to plug things in until we just have y prime by itself, though. So we want to know what x is. How far has this gone? It says it's traveled 126. Oh, there it is, right there. It says at this instant it's traveled 126 miles. This boat traveled 126 miles south. So we've got that. 126 for x. 30 in for x prime. And then we need to know what y is, because we can only have y prime as our variable. So we can get that through this information. We know at this instant we're at 126 miles away. If we add that to 172 squared, that should equal our hypotenuse squared. And this will allow us to solve for that y, and then we'll have just one variable like we wanted, right? So 126 squared, and then we got 172 squared. Add those together, and then we want to take a square root. So I got 213.235 for y. So this left side is 2 times 213, and then this is y prime. So it's just a little bit of algebra to finish solving, right? Got to divide both sides by 426.427 roughly. So 2 times. So 17.7287, or in other words, 17.73 to the nearest hundredth. 17.73.